Okay, on this next one, we have a lot to do, so I'm going to be really careful in each step. First, I notice I have a distributive property on this side. It looks like I am distributing a negative, and really what I'm distributing, if I don't see it, is I'm distributing a -1. So that implied -1 is going to be multiplied by both of the terms that are inside the parentheses. So bring down my -11d. -1 times 2d is -2d. -1 times 4 is -4. On the right side, I'm going to multiply 2 times -5d to get -10d. 2 times 3 is +6. And everything outside the parentheses I just bring down. So I'm now going to look for some like terms. I have a -11d and a -2d. That makes -13d. And the -4 just stays on there. He didn't have any like terms. Over here I have a -10d and a -3d. That's going to make -13d. And then I have a +6 and a -10. That makes -4. Looks like I have the exact same thing on both sides. Let's see what happens next. So I am going to add this variable to both sides. When I do, I notice both of these will make 0, and I'm left with -4 equals -4. And I ask myself, is that statement true? Is -4 equal to -4? Yes, it is. Therefore, there are infinitely many solutions. So I can replace d with any value I want to, and the left side is going to equal the right side on this equation. Okay, on the left side we have the distributive property. It looks like, again, we have a negative without a number. So there is an implied 1 there. So I'm going to be taking that -1 and multiplying it by both terms that are inside the parentheses. -1 times 3 is -3. -1 times -6f is +6f. On the right side, I have 6f plus 5. And there it is again. Those two variables have the same value. I have a 6f on the left and a 6f on the right. So when I subtract 6f on both sides, what am I going to be left with? And you might be getting to a point where you can actually stop right here at this step and notice that these two values are not going to equal each other. And if you can stop there and notice it, you do not have to keep going to this step that I'm on right now, because at this point we realize that -3 is not equal to 5. So since -3 is not equal to 5, there is no solution. No value of f can be replaced so that the left side and the right side would equal each other in this equation. Okay, I have two different places where I have to use the distributive property here on the left side. So I'm going to start with -5 times 1 and -5 times -5x. -5 times 1 is -5. -5 times -5x is +25x. 5 times -8x is -40x. 5 times -2 is -10. I'm going to bring down my equal sign and bring down the right side. And you could also have combined these two like terms in that step. I'm just going to wait to the next one. So now I'm going to look for like terms on the left side. It looks like -5 and -10 are like terms, as are +25x and -40x. I like to start with the variable. So +25 and -40 make -15x. -5 and -10 make -15. On the right side, these are like terms. So I have a -12x. So now I'm going to look for the smallest variable. When I first look at it, I start by thinking, oh, 12 is smaller than 15, but I realize they're both negative. So really -15x is smaller than -12x. So I'm going to add 15x to both sides. And remember, the reason I always choose the smallest variable is so that hopefully I end up with a positive coefficient here at the end to divide by. I don't want to divide by a negative and then forget about my sign. So it's easier when I'm left with a positive. So here I have a 3x, so I'm going to divide both sides by 3. -15 divided by +3 is -5. And of course here, 3 divided by 3 is 1. I'm left with that 1x. So negative 5 is equal to x. Okay, so we are going to, on the left side, it looks like I have some terms I could combine. On the right side, it looks like I have some distributive property. So I think what I'm going to do here is I'm just going to bring this down right now and wait to combine my like terms when I do that on the right. And I'm just going to right now worry about this distributive property. So 2 times p is 2p. 2 times negative 3 is negative 6. Negative 2 times p is negative 2p. Negative 2 times negative 2 is positive 4. Okay, on the left side, I'm looking for my like terms. So I have a positive 1 and a positive 5, and then I have a positive 8p and a negative 4p. I like using my variables first. 8p and negative 4p make positive 4p. 1 and 5 make positive 6. On the right, my variables are 2p and negative 2p. That actually makes 0. So I'm not going to write 0p. I'm just going to not place a p on that side. And then I have a negative 6 and a positive 4, which makes negative 2. So over here, I actually only have one term, which means that I can skip my usual next step. The usual next step is to look for the smallest variable on each side. I don't have to do that because I already only have one variable in this problem. So all I have to do now is get this variable by itself on the left side by subtracting 6. Sometimes it seems confusing when a step is skipped and it ends up a little bit different than what we're used to. 6 and negative 6 make 0. Negative 2 and negative 6 make negative 8. And now I'm going to divide both sides by the coefficient. So p equals negative 2. Okay, I'm going to go ahead and write out this next step for distributive property in case you struggle with fractions. Okay, remember that when I multiply a fraction times a whole number, and I'm going to go ahead and write both of those. I have a positive 3 over 2 times a positive 6. Remember, it's like I have a 2 over 1 here. Here it's like 6 over 1. So we can multiply across the top and across the bottom and then divide. We can also do something where we reduce this way. We can simplify diagonally before we get started. So I notice that I have a 2 and a 2. Both of these numbers are divisible by 2. 2 divided by 2 is 1. So I'm going to cross out that 2 and make it a 1. 2 divided by 2 is 1. So now I'm going to multiply the numbers I have left. I have 3 times 1, which is 3 on the bottom. My denominators are 1. 1 times 1 is 1. That x is still there. So here I got 3 over 1x, which is the same as just 3x. Okay, if I look at the next multiplication problem, I'm going to do the same thing again, where I notice diagonally I have a 2 and a 6. I can simplify by dividing both of these by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So now I'm going to take my new numbers, my 1 and my 3, and use those to multiply across the top and across the bottom. 3 times 3 is 9. 1 times 1 is 1. And 9 divided by 1 is 9. It's positive, so I'm going to put a plus sign there. Okay, I'm going to go ahead and bring down this right side that I didn't really have to do anything with. And look what I notice now. Both the left and right side are exactly the same. So what does that mean? Try to think ahead a little bit. Well, when I subtract 3x on both sides, what am I going to be left with? Well, I'm going to be left with the same number on each side. I have a 9, and over here I also have a 9. When my variables are gone and all I have are 2 constants, I ask myself, is it true? Is 9 equal to 9? It is a true statement, therefore there are infinitely many solutions. No matter what value I replace in for x, the left and the right side will equal each other.